Hi, I'm Tom Corcoran, Principal AI Specialist with Red Hat. Welcome back to our series of demos on a use case featuring AI-based image recognition from edge to cloud. Previously, we set up and ran the real-time inferencing demo. In this video, we'll show you how to train the model for your purposes. So, to recap, our series of demos consist of image capture from a webcam at the edge, sent via Kafka to a Kubernetes cluster, and then each image that the controlling application pulls from Kafka, it asks this AI model whether it's a person or a background, and then it keeps a track of that, and then a dashboard updates in real time. This is the part of the demo that we're going to focus on today, where you can we show you how we train the model and show you how to use it for images that you're interested in for your use case. So again, let's let our GitHub documentation drive our demo like before. And like before, we've also set this demo up previously to save time. So the first thing that you'll need to do is to go to this administrator setup. Again, we've split our docs up for classroom type situation. I'm just going to show you what you need to run end to end. Some of it will be the admin stuff. Some of it will be what the class students do. So first thing you need to do is install the Open Data Hub's Jupyter component. It's a authoring environment for data science, and that's where we're going to train our model. So first thing you need to do is go to where you've cloned the repository on your laptop and navigate to the setup, training, and open up the workshop def file. Then go to your browser with OpenShift and copy out the section in the address bar of your browser from .apps as far as .com, and then replace what's on line 41, which will be different, with your actual value here. Save the file, and then you run this here, and then you navigate to workloads, pods, and you filter on Jupyter Hub. So let's actually show you that in action. So first thing is to extract out the .apps as far as .com, copy it, go to your environment where you've cloned the repo, setup, training, workshop, dev, paste your value in there, save the file, and then go to terminal and then paste and hit enter for these two items. That's going to install Jupyter Hub. Within a few minutes, it takes about 5 minutes, you will need to go to the pods view, filter on Jupyter. Whenever you see it has completed the deploy and the DB deploy have completed, then you're ready to open up Jupyter Hub. Go to your networking routes inside of your admin view, find Jupyter, click on it, and then you'll be on your way in. So let's go back to our docs. So we're going to ignore what's after this section because we can pick it up in the last document here, which is item 6. First thing you want to do is gather your credentials. So to do that, you go copy login command and follow the things through, and you'll end up with a string like this. The first part of that, after the word token, as far as the bit before server, is your API login token. The next bit after server equals is your server. and then copy these values here into a text file and replace your values for this one and this one here. You're going to need these in a second. So I did it in a text file like this. You take your username, whatever you're logged in as, on the top right over here, and then your login server, your value, login token and login server, your values here and here. Paste those into a text file. After you hit your, all right, let's go back to our docs. Then you go to networking routes, like I showed you a second ago, and you open the Jupyter route. You'll be requested to authorize access. And then you enter, you select this image item, you select a large size, and then you hit add more variables twice because you want to add the 3 variables here. Your username and your actual username, login token, and your actual login token, login server, your actual login token, and then hit start server. So I'll show you. This is what you'll see after you click on this route. You'll see this page. So like I said in the documentation, choose this predictive maintenance TensorFlow, hit add more variables 3 times, and enter your login server and its value, login token and its value, username and the value, and then you go start server. I've actually already done that, and this is what you'll see a few minutes later. It takes a bit longer the first time because the image is being downloaded. Let's see what's next. Then what you do is you need to copy this URL to our GitHub repo, because you're going to clone this and pull down the model training Python code to your OpenShift Jupyter Hub environment. When you're in, you just click on this item here, clone a repository, you hit enter, or you paste in your repository, and then you click clone. I'm not going to do it because I already have. A few minutes later, you'll see this predictive main folder here. So then what we need to do is to actually run our Jupyter notebook that trains our model, that basically directs other Python files to do the model training. So let's show you where that is. It's, you navigate down inside of predictive main, inside training, inside notebooks, and you open up this scene selection, scene change detection notebook. Depending on how you want to do it, you can walk through each individual cell by hitting Shift and Return, which will go and execute each particular cell. Or if you want to run them all at once, you can go kernel, restart kernel, and run all cells. Either one will actually execute the entire notebook. So let's see what we're doing. Yeah, we then walk through each individual cell. So let's just give you an idea of what's happening. Just with Jupyter, you could see that we have documentation and output and visuals, as well as code execution. So it's a very useful environment. We just set up some imports and we set up a variable where our code is here. Initialize some hyperparameters, define a storage server where we're going to send our output to. We also use MLFlow, which is a model registry where all the details of our experiment are registered, but it's something that you can look into. It's on the routes over here, the MLFlow. You can log in using your OpenShift credentials. We do some processing here, basically pull in some sample images here, and we sort of treat or modify them to allow us to train our data. Then we just do some training here. We compile the model and we train the model. You see this epochs 3. It's hopelessly inadequate, but for speed, I've just left it at 3. Basically, the number of epochs or epochs is the number of times that the training goes through the entire training set. You probably want to have it tens or 100 times instead of 3, because it gets more and more accurate as it goes through the training. When the model is compiled, then we deploy the application into OpenShift using the Seldon component that's going to wrap it behind the RESTful API. This takes up to 10 minutes, so bear with that happening. Then we output the route that OpenShift has created for us. So if you look over here in the routes, this route here, this URL here, is the URL that your model will be exposed to clients to call it. So you need to just be aware that it's also output, and we'll show you where you can use that if you want. Okay, so let's go back. Finally, we test out our model. This is an image here that represents this. That's clearly not a person. And we're going to test out our model using that. We build up some JSON here that we're going to wrap this image into in the form of a multi-dimensional image array representing the pixels in this. And then we simply post the call and ask the model via this API what's in there. And you can see here that it's come out as background, which is indeed correct. And then this is just the code that allows us to make that prediction, and we're done. One thing I wanted to point out for you, inside of the file training source modules build model.py, which is this one here. This is our AI model. This is an out-of-the-box, off-the-shelf model that we've downloaded called EfficientNet. That's basically where the image prediction happens. And then we add a couple of extra layers ourselves to that to just customize it for our own purposes. But really, that's where most of the model intelligence comes from. Just FYI. Let's go back here. So here's just the instructions on how to run it. A little bit of troubleshooting. Sometimes this cell where we wrap the model, where we wrap our image inside of a JSON, comes out with an error. If it happens, just go to this and go Shift-Enter, and it should, after a couple of attempts, run correctly for you. The other way that you can test this model is using Postman. So if I look at this, obviously a second ago, you saw that I trained or I tested the model using that background, using that car park image. I've actually converted that into a multi-dimensional array over here. So these are basically the pixels that are in that image. And you can actually test it out with a tool called Postman if you want. It's completely adequate and probably preferable to do it the same as we did it inside of the notebook. But if you want to actually see it in action using an API call, you can output or you can use this URL inside Postman, set up a post request. Incidentally, we actually output what the URL is just up here. So this is the inference URL. So in cell 4.1, you'll be able to get the actual. So that's the route. And then you append API v1 predictions. That will output for you. And then you paste in the ones and zeros here that come from that link that I just showed you over here, accessible by clicking here, representing that actual car park image. And we can make that API call here and ask the model what's in that. And it indeed does predict background the same way as you saw happen within the notebook. That's really the end of the demo. Oh yeah, one last thing. If you go to training data, raw data inside of your notebook. So inside of your Jupyter, you go to training data, raw data. You can see that simply by providing folders and images within there, that's just one of me. And you want to have a lot more than 10 images, but these are images containing people. And similarly, we have one with background. By placing your own images for your own use case in there and training the model, it will detect those items. So this is very extensible, easily extensible, and very powerful. So just to close out, these are the tools, the open source tools that we've used. And these are the actual Red Hat implementations of all these open source tools that we've used. If obviously the instructions are available here, as we indicated earlier. Please contact me if you'd like to drill any deeper. What we can do is provide you with a technical overview of Red Hat and AI/ML. You can check out these websites here, and you can check out our YouTube channels, ML with Red Hat and AI/ML on OpenShift. So that's it from me. Thanks for watching. Hope you enjoyed the series.